like doing the last time? Anyone? We were with definite integration, right? We were doing definite integration. So we'll continue with that, and then the last thing that we did were the properties. And after that, as you can see here, right, we were gonna do integration, definite integration by parts, correct? So definite integration by parts, you might have known this, like how to do and all, I know. But let's again look at this. What is definite integration by parts? First, all of you all, please let me tell, or you please tell me if my voice and video, all the screen sharing is audible or not. Then we'll move the lecture, proceed the lecture further. All is good? My voice, the screen share part and all. Come on, guys. You can give me a thumbs up if it is good. Hello. Is it fine? Can we start? Give me a thumbs up if it's fine. All good? Okay, okay. Chalo. Let's start then. Right? If any issues, let me know. Okay? Chalo. So here, I just like, there is no, I don't think there's a need to give you a formula. We'll look at it with an example. Correct? Let's look at it with an example. So here the question says, if f of 0 is 1, f of 2 is 3, and f dash of 2 is 5, then find the value of integration 0 to 1 x f double dash of 2x dx. So what we need to do in in integration by parts, we need to select the first function and the second function. Usually we select the second function, which is integrable. So what you can think of as the, should I select first function and second function? What should I do? What will be x? Will it be the first function or the second function? Chalo, you can tell in the chat box. Let me know if you know. Let's make it more interactive. So I am asking x को क्या लेंगे? X को what we should we take? The first function or the second function? So automatically I'll know कि दूसरा वाला second या first function है. X को क्या लेंगे हम लोग? चलो come on. No one? Come on guys. X को क्या लेंगे? What will take this x as? First function or second function? Array, 6 people are there. No one knows. First. Very good. Thank you. So we'll take x as the first function because why? Because we have to integrate the second function. And as you can see, this is already twice differentiated, f double dash of 2x. So that means we need to take f double dash of 2x as the second function because we need to integrate it. So let's look at the formula. Okay, what was the formula if you remember? U, or first function, as it is. Integration of second function means f double dash of 2x dx. And the limit is on all from 0 to 1. Minus, here it is 0 to 1 bracket. Integration of second function and derivative of first. So integration of f double dash of 2x dx into derivative of x, the whole dx. So here, just note that the limits here are on the full bracket and here are on the integral sign only. So this is the definition of like how this is how we use definite integration by parts. So here, what is integration of f double dash of 2x? It is simply f dash of 2x, correct? From 0 to 1 minus here integration 0 to 1. What we'll get here? Integration of f double dash of 2x. Am I missing something here? Yes, we are missing divide by 2. Do you remember? We divide by coefficient of x. So here it is 2. So therefore, we need to divide by 2. Similarly, here I'll get f dash of 2x upon 2 into 1. Derivative of x is 1. And again, here I'll get x f dash of 2x upon 2 from 0 to 1 minus. Here I can take 1 by 2 outside. What will be left with? Will be left with f dash of 2x. What is integration of f dash of 2x? F of 2x upon 2. And here again the limit will be from 0 to 1. Correct? All good? So now what we'll do? We'll do upper limit minus lower limit. So here upper limit may will get 1 into f dash of 2. 2 into 1 आएगा, but that 2 into 1 is 2 upon 2 minus lower limit may will get 0 because x is 0. Correct? 0. And minus again here we'll do upper limit minus lower limit. So upper limit में क्या आएगा? ये 1/4 तो बाहर ही रह जाएगा. Denominator का 2 multiply होके 2 2s are 4. So what will get upper limit? F of 2 minus f of 0. Correct? So finally मेरा आंसर क्या है? F dash of 2. F dash of 2 is 5. So basically I got 5/2 minus 1/4 into f of 2. F of 2 is 3. 3 minus f of 0. F of 0 is 1. So that means 5/2 minus 2/4. 2/4 ko I can write 1/2, which is 4/2, which is 2. So this is my answer. I hope it is clear. Just don't forget this part, this 2. ये 2 कहाँ से आया? Because it is coefficient of x. Coefficient of x. Correct? Any doubts here? If no doubts, give me a thumbs up. So we'll proceed further. Chalo. All good? Understood till now? Give me a thumbs up. It is an important part. Integration by parts. A small part, but very important part. Like it will come in next questions. You can tell me. All good? Then we'll proceed to the next question. Give me a thumbs up if it's all good. All good? Hello? हाँ, no one? नहीं समझा? Should we move on to next? Okay, fine. Chalo. So next, as you can see, I have already moved on to the next. It is Leibniz rule. So Leibniz rule, you might know, it is also known as differential under integral sign. Basically just a fancy way of saying derivative of integration or derivative of definite integration. As we all know, कि integration and derivative both are opposite of each other, or you can say it's like inverse functions. Both are inverse functions. So what do I mean by inverse function? I mean that if someone asks me d by dx of integration something dx, then this and this f of x ले लो gets cancelled and I'll get simply f of x. Correct? And same vice versa. अगर integration of d by dx पूछा है तो वो भी मेरे को same ही मिले. But here, what is the issue here? Here it is that we have definite integration. So after integrating, we need to do upper limit minus lower limit and then differentiate. and then differentiate. So itna like instead of doing so much, Leibniz gave a Leibniz rule. What we'll do is, see here, please note some very important points I'm gonna say. Here, the function is f of t, like the function is in terms of t, but the limits are in terms of x. The limits are in terms of x, that is, limits are in terms of x. And we need to differentiate with respect to x. Logical cheese, na? If I integrate and I'll do upper limit minus lower limit, then I'll get a function in terms of x. So g of x रखूंगा और h of x रखूंगा. And that function in terms of x, I need to differentiate with respect to x. So it's logical. So basically what happens is, here we'll get f of t or function in terms of t, the upper limit, lower limit, and the differentiated with respect to will be with the same variable. अगर upper limit, lower limit x के terms में नहीं है, if the upper limit and lower limit are not in terms of x, suppose they are in terms of w, then we will differentiate with respect to w. Got it? So let's move. What Leibniz said, key to get this, the answer of this, you just substitute upper limit in the function. So I'll get f of g of x and into derivative of upper limit minus f of lower limit into derivative of lower limit. I have very much written here how to read Leibniz rule. What do you mean by how to read Leibniz rule? How to read Leibniz rule means कि confuse ना हो इसके लिए. F of upper limit into derivative of upper limit minus f of lower limit into derivative of lower limit. बराबर, very simple, कुछ नहीं करने का. F of upper limit derivative of upper limit minus f of lower limit derivative of lower limit. So let's simply look at this example on how to apply the Leibniz rule. Correct? अच्छा, let me tell you Leibniz rule क्यों हम यूज करते हैं, because I told you कि if Leibniz rule was not there, what we must have done, we must have simply integrated this function. We must have done upper limit minus lower limit, and we would have got some g of x. And वो function का what we would have done, we have taken derivative. So what does this mean? Sometimes the function given may not be integrable. If you are getting it, sometimes the function given may not be integrable. So it will be not be possible for this method. What we can do here is, we can use Leibniz rule. Leibniz give a very nice, or you can say a short path to the derivative of integration. So what is, remember this, the box one. What is f of t? This part, cos of t square, is f of t. So according to Leibniz rule, क्या बोलता है Leibniz rule? F of upper limit. What is f of upper limit? F of root x. Correct? Into derivative of upper limit means derivative of root x minus f of lower limit is f of 1 by x into into derivative of lower limit, which is derivative of 1 by x. Simple. This will be my answer. What is f of root x? Acha, let me write it here. Yeah. F of t. F of t is cos t square. So what will be f of root x? F of root x will be cos x. Root और square cancel हो जाएगा. And f of 1 by x. What will be f of 1 by x? It is cos of 1 by x square. Correct? So let's substitute these values. What will get? Cos x into derivative of root x is 1 upon 2 root x. करेक्ट? मिस्टेक नहीं किया ना? नो. या माइनस cos of 1 by x square into derivative of 1 by x is minus 1 by x square. So finally what we got is cos x upon 2 root x. Correct? Plus a minus and this minus will give me plus cos of 1 upon x square upon x square. This is my answer. Got it? It's very simple. Just remember this. F of upper limit into derivative of upper limit minus f of lower limit into derivative of lower limit. Yeah. Chalo. If it's clear, we'll move on to the, we'll see some questions, some good questions here. Let's do. All good? Clear till now? Give me a thumbs up. If it is clear, give me a thumbs up. Then we'll move on to the next. Chalo. Okay, superb. Let's move this question. The question says, this is actually came in previous year CET exams. CET, you understand, I hope. Not JEE, CET exams. JEE or previous year JEE will do the next question is from that one. So it is given x is equals to integration 0 to y dt, and this is equals to this. Then we have to find the value of a. Chalo. What will be the value of a? So that means we have to differentiate y, or we have to differentiate twice from with respect to what we have to differentiate? With respect to x. Correct? So let me tell you the first time when I did this sum, I was somewhat amazed. Ki, here we have to differentiate with respect to x. But here the limits are in terms of y. So according to Leibniz rule, if you saw here, this, whatever are the limits, we can differentiate with respect to that. Here the limits were in terms of x. That means we need to differentiate with respect to x. Here the limits are in terms of y. So we need to differentiate with respect to y. Very important star mark. Differentiate with respect to y. Because why? Because why? It is here the upper limits are in terms of y. Implies if we differentiate with respect to y, we'll get, what we'll get in the left hand side, it is x. So we'll get dx by dy. Now, once we get dx by dy, I can write dy by dx is equals to, what will something will come? By just taking the reciprocal. And once I got dy by dx, I need to again differentiate and I'll get d square d2y by dx square. This. And then from comparing, we can easily find a. So if the method is clear, let's move on to step by step. What will do? Differentiate with respect to y. So I'll get dx over dy is equals to, what was the formula? Do you remember? F of upper limit. This is f of t. So f of upper limit means f of y into, I'm differentiating with respect to y. So derivative of upper limit minus f of lower limit into derivative of lower limit. So derivative of 0 is 0. That means this all part will get cancelled and I'll get 0. Now what is f of y? F of y, just put y in terms of y in place of t. So I'll get 1 upon under root of 1 plus 9y square into derivative of y is 1. So finally, I got dx by dy is equals to 1 upon under root of 1 plus 9y square. So what will be dy by dx? Therefore, dy by dx will be reciprocal. That means under root of 1 plus 9y square. Got it? Let's mark it as 1. So now I need to differentiate with respect to x and I have y here. So that means we have to use chain rule. So if I again differentiate, so I'll get d2y by dx square is equals to root x का derivative 1 upon 2 root 1 plus 9y square into by chain rule इसका derivative, so it will be 9 into 2y into dy over dx. I'll mark this as 1. I'll mark this as 1. Right? Do you understand? Did you understand this chain rule? Very simple. This 2 and this 2 will get cancelled. So finally, and from 1, we can put dy over dx as this. See, we can use dy by dx here. Like we'll substitute this. Correct? So what will I get is 9 into 9 को आगे ले लिया 1 upon under root of 1 plus 9y square. अच्छा 9y है ना, y को भी will take outside this y. So 9y into what is dy by dx? Under root of 1 plus 9y square, and to our surprise, this will get cancelled and we'll be left with 9y. And d2y by dx square, it is given ay. That means what is the value of a? A ka value is 9. This is my answer. Simple. Got it? A is equals to 9. If it is clear, then we'll move to the next question. Give me a thumbs up. Come on. All good? All good, all good. Chalo, you can give me a thumbs up. If you have any doubts, you can ask in the chat box. Or you can unmute yourselves also. Come on, guys, all good? Okay, superb. Chalo, let's move forward. Let's look at the next question. This isn't like good question. Let a function f is defined from R to R and some values are given. Then we have to evaluate this. Here we have limit. Correct? Now, let me tell you one interesting thing about the Leibniz rule. Leibniz rule is only applicable, if you saw here, when the function and the upper limit, lower limit variables are not mixed. What I mean is, here I can write this as for integration, the variable is dt. That means I can write this as limit x tends to 2. I can remove 1 upon x minus 2 because for integration, it is with respect to dt. That means the variable here is t. So I can write it as integration 6 to f of x 4 t cube dt. I can also remove 4 outside, right? 4 भी तो एक constant ही है. So I can write 4 upon into integration of 6 to f of x t cube dt. Now, we can use Leibniz, but there is no need to use Leibniz because I'll tell you, there is like actually we can easily integrate this function, right? T raised to cube. We can integrate t cube. T cube ka integration is t raised to 4 upon 4. So let's integrate and then we'll check. So we'll get limit x tends to 2. Don't take x minus 2 outside because for limit the variable is x. For limit the variable is x. So we cannot take it outside. So I'll get 4 upon x minus 2 into. This is a tricky question somewhat. If you don't know the basics, then you will will stuck in this. We know, again, I'm repeating, for integration, it is dt. That means the variable is t. That means only we need t cube. These rest of the terms are constant. Rest of the terms are constant. Bhale fir it is in x or something. We can take it outside. So what is integration of t cube? Integration of t cube is t raised to 4 upon 4 from 6 to f of x. This 4 and this 4 will get cancelled. Correct? I'll put a bracket here so it will be more on this. Yeah. So what I'll get is limit x tends to 2, 1 upon x minus 2 into. Here what we'll do? Upper limit minus lower limit. So f of x, the whole raised to 4 minus 6 raised to 4. Now we have to again evaluate limit. So basically limit x tends to 2. What will get? F of x raised to 4 minus 6 raised to 4 upon x minus 2. If it is a question on limit, then we'll check the indeterminate form. Let's check the indeterminate form. We'll put x equals to 2 here. So I'll get f of 2 raised to 4 minus 6 raised to 4 upon 2 minus 2. What is f of 2? F of 2 is 6. So 6 raised to 4, 6 raised to 4, it is 0 by 0. So since it is 0 by 0 form, I'm rubbing it because I think I'll not have space. So, okay, never mind, we'll have space. So it is 0 by 0. It is an indeterminate form. So what we can do, we'll use सबसे best, the L'Hopital's rule, or as we would like to say, LH rule. Limit x tends to 2, we will take derivative of numerator. I'll get 4 f of x raised to the power 3 into f dash of x. Chain rule, minus 6 raised to 4 ka derivative 0 upon 1 minus 0. Now once the indeterminate form is gone, we'll substitute directly the value of x. So 4 f of 2, the whole cube into f dash of 2. Simple. This is my answer. And we have the values, right? Yeah, f of 2 is 6. So 4 into 6 cube into f dash of 2 is 1 upon 48. So I am not very interested in calculation, but we'll do here. So we can write it 12 4s are 48 and 6 6 are 36, right? 36 6 are 216. 6 ka cube is 216 है कि 256? 216 है ना? Yeah, it's 216 upon 12. So we'll get 12 ones are 12, 12, 8. My answer is 8. Got it? So this is my answer. So many a times, like if we think we need sometimes Leibniz rule, but it is not possible because we can easily integrate it. So no need to use Leibniz rule here. Okay. These questions also come. What we can do next? Got it? All good? Give me a thumbs up if it is good. Then we'll move to the next question. Come on, guys. All good? Yes, no? Any doubts you can ask? Give me a thumbs up if it is all good. Hello? All good? Okay, fine. Chalo. Let's move on to the next question. This. This is a very like good question, which is previous services, previous JEE mains. It is, I guess, 2020 or 21. Chalo. Now, in this question, they have mixed the concept of application of derivatives, or you can say tangents and normals, and the Leibniz. They have mixed these two concepts, tangents and normal and Leibniz. And also you can say straight line, because a slope point form comes in straight line. So they mix two, three concepts here. And if you see, I keep telling students ki, we cannot expect questions on only one concept for JEE. They will at least try to mix 2 or 3 chapters and they will give it here. Don't worry, the question is very simple if you know all the concept, basic concepts. So what is given here is equation of tangent to this curve at x equals to 1. So what is equation of tangent? So let me give you the thought process. What is the thought process? Step 1. One second. Yeah. Step 1 will get the slope of the tangent. Right? Step 1 may will get slope of tangent. What is slope of tangent? It is dy over dx at x equals to 1. Step 2, very simple. Once we get the slope of tangent, we can use the slope point form. Y minus y1 is equals to m x minus x1. Now to get step 1, we need to use Leibniz. As you can see here, we have integration. We need to use Leibniz. We need to use Leibniz. Right? So what we'll do here, differentiate with respect to x. So I'll get dy over dx will be equal to d by dx of integration x square to x cube dt over under root of 1 plus t square. Now, do you remember Leibniz? Leibniz says upper limit f of x cube into derivative of upper limit, derivative of x cube, minus lower limit or f of lower limit, f of lower limit minus derivative of lower limit. So I will get f of x cube. F of x cube will be 1 upon under root of 1 plus x raised to 6. 2 पहले से है ना, 2 is already there and cube आ गया, तो it will be 6 into 3x square minus f of x square. What is f of x square? 1 plus x raised to 4 into derivative of x square, it will be 2x. Now this is dy by dx. So for slope of tangent, what will be slope of tangent? Dy by dx when x equals to 1. So substitute 1 here. What I'll get? I'm skipping one step. So here I'll get 3 into 1, 3 upon 1 plus 1, 2. Barabar? Yes. Minus, here I'll get 2 upon root 2. So what is this? 3 minus 2, so 1 upon root 2. So 1 upon root 2 is my slope. And once we got the slope, we can directly write x equals to 1. Achha, we now need point, right? x1 comma y1. Got it? So we have x equal to 1 implies y equals to integration. We substitute x equal to 1 here. What I'll get? 1 square is 1. 1 cube is 1. So integration of 1 to 1 dt over under root of 1 plus t square. Now, if you remember, here we must remember the properties of definite integration. The integration of a to a f of x dx is 0 if the upper limit and lower limit are same, and if you can understand, like no area is covered, right? So that means we will get 0. So that means y is equals to 0. So implies what are my points? 1, comma 0 is x1, comma y1. So my equation will be y minus y1 is equals to slope of tangent is 1 by root 2. 1 by root 2 into x minus 1, which means I can cross multiply root 2. So root 2y is equals to x minus 1, or I can rewrite as x minus root 2y minus 1 is equals to 0. Simple. This is my answer. Okay, so it was a very good question, which was based on 3, or you can say 2 things: tangent normal, the Leibniz theorem, and equation of line or the slope point form. Got it? If it is all good, then we can give me a thumbs up and we can move on to the next part. All good? Give me a thumbs up if you understood it. You can see the question once more and then we'll proceed next. Take your time. Okay, good. All good. Still, I'm very disappointed that only one of you are giving me answer. I don't know why. Is there some problem? Like for others, no problem in chat, like giving thumbs up or chatting and all, right? I mean, technical problems. You can have personal problems. You may be partying or in the ground or something. But if any technical issue, let me know. Okay. Let's move. So if it is clear, then we can move on to the next. So I hope these questions are clear. The Leibniz rule, how to use Leibniz rule. These were some basic questions we did. Okay. So now next is a very important part which I would like to start, which is definite integration as limit of a sum. What is meant by this? So basically, you can say this is called like how definite integration came, like how definite integration was discovered. So basically, if you know, integration is a continuous process of summation. Definite integration, when you studied for the first time, this was a statement you must have seen or heard somewhere from your friends, teachers, in some books and all. Or definite integration is a process of summation. So that what means here, definite integration came by continuously adding some function. By continuously adding some function. Now, you can say definite integration is a smooth addition. Why smooth addition instead of some random addition? Let me give you an example. There are two cases. One of the case, 1 second, whatever. Suppose let's say this is the curve and we have to find area between these two, right? So what is continuous process of summation? Like we took these rectangles. We took this rectangles. Like we divided very short rectangles if you remember the first principle of definite integration, it is called, right? So that way we kept adding these rectangles. If we kept adding these rectangles, you can see we can easily get the area, but this, the blue highlighted area will be missed, right? If you can understand. Suppose this is y equals to f of x. This is from A to B. So we need this whole area. So in continuous process of summation, what we did, we divided the area into strips. We call it as strips. This we will talk about. Definitely we'll talk about in area under the curve, which is our next part. But I'm not going, that's why I'm not going into very deep here. So if we divide into strips, vertical strips, you can see the blue area will not be covered. That means by continuously adding the area of these rectangle strips, we will not be getting the exact area under the curve y equals to f of x. Again, I'm repeating, if we add the area of these rectangular strips, what is area of rectangle? Base into height, or length into breadth, you can say. So if we continuously add means summation, still we will be not getting the blue highlighted area. So for that, what we did, we used limit. What does limit do? Limit will make the blue highlighted area very, very, very small, like tends to 0. Limit will be tends to 0. Got it? This breadth h will be tends to 0. If this h or the length is tends to 0, then if it is very small, then you can imagine ki the number of strips will become infinite. Like I can also draw very large strips like this, which have large length. I can also draw very small strips like this small. So if the strips are small, means the h or the width is very small, then the strips will become infinite. That means n, which is number of strips, will be tending to infinity, or you can say h, the width of the strip, will be tending to 0. Anything we can use. What did we can use? Anything. So by using limits, if you can imagine, this strip will like almost have no width, then all the blue marked areas will be gone. We will cover all the areas. That is the basic idea here. Key, how to avoid the blue marked area, like how to get rid of the blue marked area. So for that we use limit. So limit is a very helpful tool, and continuous process of summation plus limit will give me integration. So you have to just remember this. Basically, it's a formula. Formula है तो learn तो करना पड़े. So what we did here is same. This is done by summation notation with limits. Like it is called first principle of definite integration. So what is integration 0 to 1 f of x dx means? It means it is limit n tends to infinity or h tends to 0. Summation r equals to 1 to n, 1 upon n f of r by n. Correct? That means if we have this, we can write it as integration 0 to 1 f of x dx. Got it? If we have this, we can write it as integration 0 to 1 f of x dx. So here let me write it key f of r by n, like r by n on the right hand side got replaced with x. If I replace r by n with x, I'll get f of x. The summation sign from r equals to 1 to n got replaced by integration 0 to 1. And this 1 by x got replaced, sorry, 1 by n. 1 by n got replaced with dx. Got it? So you have to remember these three things. We can, we have to generate this, or we have to manipulate the given equation or given question into this. After we have done this, we can replace r by n with x. So we'll get f of x, 1 by n with dx. So f of x dx, and this summation with integration 0 to 1. If we replace it with integration 0 to 1, my RHS will be converted to this, and we can easily solve this question. Got it? You will be more easily understanding if we solve one of question. Let's look at the question. Yeah. Now, please remember what we need. We need summation notation. We need r by n. We need 1 by n. These three things we need, because then we can convert it into this. So we need r by n. We need summation notation. We need 1 by n. So let's, by using our sequence and series concepts, let's talk about this. Here, we need summation notation, right? So can you think how we can get summation notation if you know sequence and series? Anyone? Should I take something common or as such? For getting 1 by n, what I'll do here is, see, I'll do a very interesting thing. We need to have 1 by n, right? We need to have 1 by n. Then we can convert it into dx. So what I did is, I took 1 by n common from each of these terms. If I take n square common lunga, basically, if I take n square common from under root ke bahar aake, that will become n. So I'll get 1 upon, okay, I'm not skipping a step, or else you'll get confused the first sum. So I'll take n square common. What I'll get is 4 minus 1 upon n square plus. Similarly, I'll take n square common from here. What I'll get is 4 minus 2 square upon n square. We can write it as 1 square also. Plus plus 1 upon, if I'll take n square common, n square to pehle se common hai. We can write it as, if you know, we can write this as, wait, let me write it here. We can write this, the last term, as 1 upon 4n square minus n square. So I'll get 3n square. Correct? I can write it like this. So if I take n square common from here, I'll get n square into 4 minus n square upon n square. Clear? I'm not cutting this n, or if you know, my pattern will get disturbed. Like sequence and series में क्या करते हैं हम लोग, pattern observe करते, then we generalize to get summation. Now all these n squares will come outside of square root, and I'll get 1 upon n under root of 4 minus 1 square upon n square plus 1 upon same n under root of 4 minus 2 square upon n square plus plus 1 upon n under root of 4 minus n square upon n square. Now I can take 1 by n outside, so I'll get limit n tends to infinity 1 by n. Bracket में क्या बचेगा, 1 upon under root of 4 minus 1 square upon n square plus 1 upon under root of 4 minus 2 square upon n square plus plus 1 upon under root of 4 minus n square upon n square. Now the main part. We got 1 by n. So we got here 1 by n. Now we require r by n and summations. For r by n and summation sign, you see here 1, 2, n. This is ever changing. So if you know the sequence and series concept, the summation notation, how we use the summation notation, so you will agree with me writing it as limit n tends to infinity 1 by n summation. I don't know the initial value and final value, so I'll write 1 upon under root of 4 minus r square upon n square, where r is first term में क्या चाहिए 1 square. So first term will be r equals to 1, then r equals to 2, so I'll get 2 square, then r equals to 3, so I'll get 3 square, 4 square and so on. And last में क्या चाहिए n, so r equals to 1 to n. I hope you got it. If you remember the summation notation of sequence and series, we will get this, what I've written here. I'll put r equal to 1, 2, 3, 4, 5, 6, 7, 8, so I'll get this. 1 रखा तो क्या मिलेगा 1 रखा तो क्या मिलेगा 1 square upon n square, 2 रखा तो 2 square upon n square, 3 रखा तो 3 square upon n square, n रखा तो n square upon n square. 4 will remain as it is. 4 will remain as it is. So I got all this. Now what I need to do, I need to just 1 by n को dx, r by n को x and summation को integration 0 से 1, 1 से लेके n. So what does my question become? My question will become integration 0 to 1, 1 by n की जगह पे dx, 1 upon r by n की जगह पे x. So r square by n square will be x square, right? Squaring on both the sides. I'll get under root of 4 minus x square. Got it? So this is like, these are very, very, very important questions because you can expect at least, or you can say one question will come. Like every year in JEE, they ask one question on this. If you see a actually this is a previous year question. If you like, if you know, if you have seen the past year papers, this is actually same 2021 JEE 2021. Next 2-3 questions are from JEE 2022 and the latest 2023. So you can see they like regularly ask one question on this in all the sets of the JEE. So it is important to know what we need. Again, we need 3 things: 1 by n, summation notation, and r by n. These two things to have to remember from sequence and series. You have to remember for sequence and series. So this becomes very simple. What is 1 upon a square minus x square under root of? It is sine inverse of x by a from 0 to 1. So if I write upper limit, it will be sine inverse of 1 by 2 minus sine inverse of 0. What is sine inverse of 1 by 2? Half. Half कौन सा एंगल देता है? 30 degree, which is pi by 6, and sine inverse of 0 is 0. So my final, or you can say answer, is pi by 6. Got it? So if you got it, give me a thumbs up. Come on. All good till here? You can give me a thumbs up. यहाँ तक clear है? All good, guys? Did you understand it? If you have any doubts, you can ask. Come on. No doubts? Okay, fine. Chalo. All good. Still, I'm very, very, very like disappointed. Not because like I encourage you to make the session more interactive. Keep speaking to me or to the chat box, or you can unmute yourself. So I will also get some energy, right? If it is good, then we can end the session. Like we'll have some more questions, but we'll solve it tomorrow. This one, two, two questions we have. So we'll do these two questions tomorrow, and then again, like next is the periodic functions property. So we'll do that. Right? So till then, bye bye. Take care all. We'll meet tomorrow.